Like, I didn't read it very carefully, and that's my own fault here. So we've got this cell membrane. Now, it's important to understand that this is a myelinated squid, and this is an axon. An axon is it's a nerve cell, and we know that the diameter of this is 0.5 millimeters, and it's 10 centimeters long. All right, and it's a cylinder. This is where I made the mistakes. I didn't think of it as a cylinder. But what we want to do is, we know the capacitance is this many of the membrane area. And when they say the area, it's the membrane. It is the area of, it's the surface area of the cylinder. So let me back up. The key thing to this problem is you're trying to find the energy. And if you recall the energy, sometimes we say U for potential energy, is 1/2 CV squared. That is the equation you're basically going to do. But the trick is to find C, okay? We knew the voltage. Where's the voltage? It's right here. 70, right, or negative 70. So it's just going to be 1/2 times C times, I say 70 times 10 to the minus 3 volts squared. But the trick is finding the capacitance of this object. And what they gave us is the capacitance, if you see here, the capacitance per square centimeter. So I know that it's 1 microfarad per 1 centimeters cubed. So if I found the centimeters cubed, or squared, pardon me, then once I know this number here, the centimeters squared will cancel, and that will give me C, which will be put in here. Does that make sense? So what I need to do, though, is find the surface area of a cylinder. And the surface area equation of a cylinder is going to be 2 pi r, because you have to have the surface area of the spheres, plus not 2 pi r, 2 pi r squared, because that's the surface area of the, you have two disks. And then the other portion of that will be 2 pi RH. So 2 pi RH is going to be the surface area of this portion. If you were like to cut the cylinder open, then that's what. So we have to find out what this is, and that number is going to go in here. Now, warning that they gave us the diameter in millimeters, so we know that this is 10. H is 10, but you have to figure out what R is. R is going to be 1/2 of 0.5, because that's the diameter, and that's in millimeters. And then you have to convert to centimeters. There are 10 centimeters in a millimeter, and that becomes your R. And then you plug that into here, which is just whatever this is, by the way, because it's 1 here. It's all going to be whatever your area is will also be your capacitance in microfarads. And lastly, don't forget, is that when you get your number, it's going to be like, I think, I forget, did I find a whole number? Yes, I had it wasn't a whole number, but it was a number like 1 point something. And because this is a micro, you're going to have to say times 10 to the minus 6th. So whatever you get here, since it's going to be micros, so it'll be 1/2 times whatever times 10 to the minus 6 times 70 times 10 to the minus 3rd squared, and you will get the correct amount of energy.